on this computer.
Are we using the same file today?
So you want, ideally, you guys want to start with the same analysis file, but get rid of those studies.
Okay.
So
Just take copy of the file.
yeah,
Initial.
yeah. Or if you guys don't want to keep your files and you've submitted your work for last week, which you guys should have already, you guys can just delete the studies in that same file and just create new studies there. Evan, before I start with anything, can I confirm that you can hear me?
Yep, we're good.
Sorry, wait, I have my, okay. Go ahead, Evan.
Yes, I can hear you.
Oh no, okay, I'm sorry, Evan. I cannot hear you from my side. Okay, sounds good. Thank you, Evan. I will get it going then. All right, so welcome back to FEA. We're in week 3 now, third module. Sorry, I shifted something. Yeah, right. We're in week 3, third module. So last week you guys went on about switching up your loads, the directions, a lot of geometrical stuff, right? And I know a couple of students here last week who came to class. They're asking about what would happen if they changed their mesh. And I didn't really let them do that last week because we were just focusing on setting up stress analyses last week. So this week we're gonna do the complete opposite, where we're gonna keep our loads, our directions all the same, and we're just gonna be changing up the mesh in a lot of different ways. And so before we get going, you guys can scan the QR code. This week it should work. There is going to be a question there that requires you guys to have some knowledge of the FEA stuff that we did last week. It's kind of basic, and if you guys have your Fusion 360 open, you guys can actually just get the answer quite easily. So I'm going to leave that up for about a minute or two.
Recheck the answer.
Is it? Ooh.
What is the recheck? I honestly thought to know what it says.
Yeah, I mean, you can hover over it and it gives you the name, but I mean, I'm not saying it's right, but you know, it sounds like it to me. That's what I would answer. Could you guys give me a thumbs up when you're done with the form? Thank you. All right, I'll give it another minute. Okay, so if you guys weren't able to get that, I mean, if you guys are watching the recording, then you guys could just pause and scan it. But otherwise, let us continue. So before I move on with the class, ASME has an opportunity for you guys. It's a collaboration with SWE, Society of Women's Engineers. So I'm just going to give you guys a quick overview of what this is, what this case competition is. So the National Academy of Engineering has outlined 14 grand engineering challenges for the 21st century. For this case competition, competing teams will need to come up with a new and innovative solution to any one of the 14 challenges. Regardless of the grand challenge you choose, they will be judged through similar criteria of work quality, solution creativity, and general accomplishments. The scope of this project is to have a low to mid fidelity solution ready at the time of the competition, which will be March 26, 2023. The competition will be judged by engineers from Northrop Grumman. So if you guys scan that QR code there, it gives you a very similar summary to what I just said, and you guys can actually sign up through there. So please do consider that. And yeah, without further ado, let's get into this week's module. What is a mesh, right? I mean, you've probably heard me and Bernardo talk about it like week after week. Hey, Jordan. So a mesh is basically a way that our system, in this case, Fusion 360, breaks down your model into smaller parts, which are called elements. And what the mesh actually does is it allows the system use a system of differential equations to solve for stress, displacement, etc. at each element that's generated, right? And the general rule of this is that the smaller size of your mesh, the more elements will be created. And because of that, the longer it'll take for the system to actually run your studies or run your simulations. Before I move on, just want to introduce Jordan. Jordan's our chief engineer for ASME, and he's going to be helping me out today as the TA. Yeah, all right. So, do you guys have any questions about that? Straightforward? Yeah. Okay. And let's move on.
I have a question.
Yeah.
So the kind of stuff works.
Cool.
So the differential equation should be solved for every single element.
Every single element. Yeah. So you guys remember last week? Yeah. Solve for the stress. There's a minimum values of displacement, obvious stress. Yeah, that's affected the most. Exactly. Yeah, but you have to trade that for time. Exactly. Yep. Okay. I'm gonna give you guys just so you guys have a better visualization. So this element has a size of 10 millimeters, and the number of elements in a 10 millimeter mesh is generally about 159. And it takes about 0.25 seconds to calculate each element to sort of like simulate each one. So you guys can just imagine 0.25 multiplied by 159. That's still not too bad. Let's move on. As you guys can see, the jump, it's there you go. It's a lot more. This one is 5 millimeters, and there's a lot more elements there. And of course, it'll take longer to calculate. We're gonna jump again now. This is a 2.5 millimeter element, and you guys can see the triangles just keep getting smaller and smaller. Because of that, more elements, and it takes longer to calculate for your entire model, basically. And one more. Here you go. This is really small. This is 1.25 millimeters, and ideally, you guys wouldn't want to simulate this if you guys are just making a model, like just simulating a model that we have, a fat wrench, which isn't going to be used for any practical purposes. Like we don't need it to be very accurate. But when you go to a larger scale, maybe when you guys are testing out cars and actual models that will be used, it's probably better to go with a smaller mesh to get more accurate results. And all right. So now, how can the mesh be modified in Fusion 360, right? So today is basically all about learning that. So there's 3 basic settings that we will go through today. And the first one will be average element size, which is comprised of 2 things. First one being model base size. And model base size is basically allowing the system to look at your model and make geometric relations and make the mesh based off what the system thinks will be ideal based on percentage. Of course, the higher it is, the less accurate, the less mesh you'll get. And next one is absolute size. So this allows you as users to manually put down how accurate of a mesh you guys want. And the next one is advanced settings. And this allows you to do a lot more things. I'm not going to go over them right now because we will go over this like later in class. And the third one that isn't mentioned here just yet is called adaptive mesh refinement that we will also go over in class. It's probably the end of class. We'll go over that. So I'm just going to skip through that. You guys can take a look at it for a bit, and I'm going to move on. So before we actually get to the first assignment of the day, I'd like to apologize because last week we made you guys run simulation, and then get the results, and then run another simulation, get the results. So that's probably a bit time consuming. So this week we're gonna try something different, and we're gonna let you guys sort of set up multiple studies and then simulate them at one go. And that way you guys can simulate, go back, set up another study, simulate, go back, right? So it's a lot quicker. And I'm going to actually demonstrate it to you guys, but I'm just going to give you guys the steps right now. So of course you can create like 2, 3, 4, 5, how many studies you want. Then instead of creating one and then solving it, you want to create, just keep creating studies. Like let's say you have like 2, 3 multiple studies. And once you're done, like, all right, I want to solve 3 studies, and you have 3 studies there, then you guys would go to the tree, or you guys would go to the menu up top and then solve it. And we'll also teach you guys how to compare results, to have them side by side, so you guys can actually see like visually, like, all right, the displacement of a mesh of 5 millimeters compared to a 2.51, right? And I'm going to show you guys how to do that too. Basically, it'll be up top, there's a compare, you just have to click it, and you guys can synchronize your camera. So whenever you move one of them, the one moves along with it, and the minimum and maximum values, as well as the result type. So when you guys are looking at displacement, both of them will be at displacement. You guys switch one of them to stress, both of them will be at stress, right? So, all right. So here's the task. With the same model, you guys use the 10,000 newtons one, where you guys didn't edit your y-axis value, just your x-axis. We want you guys to edit the mesh settings, and we're gonna change the average element size as well as the absolute size. So I'm gonna leave this up here in a bit, but right now I'm gonna show you guys how you guys can solve simultaneous studies at once. So, okay. Sorry, Fusion is not showing up here. Interesting. Let me go over to Zoom here. Oh no, okay. Give me a second here. So let me share my screen. Okay, just give me a sec here. So Evan, could you text me and let me know if you could see the screen now? Okay, I think this should be good. Okay, thank you, Evan. All right, so let's get back to it now. All right, this is still not working. Jordan, could you? Yeah.
So you have Fusion here, right?
Mhm.
You have it on extend. No, you don't.
Okay, there you are. There it is.
So you do have it on extend.
Yes, please.
So we're gonna go to F. And then you have to give it a second. There you go.
Okay, thanks, Jordan. All right, so sorry about that. Technical difficulties, but now I'm going to show you guys how you guys can run multiple simulations at once, right? So I'm going to go here. This is my base. And if you guys don't remember, if you guys are in design, you guys want to switch over to simulation. That's the first thing you guys want to do. So there you are, and create a new study. Oh, okay, static stress, because that's what we're going to be studying in this course. Create study. And again, we want our model to stay in place, so we have to give it a fixed constraint first. Over here, you want to make sure it's fixed, not one of these. And we want to select the whole of the bigger hole, basically, the interior of the bigger hole. Click OK, and you guys know if you did it right, if you see a lock here. Okay, let's continue. We're going to add a load now. We're going to add a force load, not a pressure, not a moment. We're just going to add simple force load here at the smaller hole, and change the angle to 180 degrees in the x-axis, in the x-angle, sorry. So there's 2 ways you could do this. You could type 180, or you could just drag this to 180 there. Okay.
You just select linear overlay.
Sorry.
You just select linear overlay.
Yeah.
Below.
And then two ways to change your magnitude. One way here and the other one here. Again, we want it to be 10,000. So there you go. 10,000. So how you guys would know you set it up right is your pre-check here is going to be green. It's going to have a tick mark here. If you guys click it, it says that study setup has all the information required. So now you can go ahead and solve, but there's one thing we're still missing. That's the mesh, right?
What's the magnitude?
Sorry,
What's the magnitude?
10,000. Yep. So two ways you guys can change your mesh. First, you go to settings. Let's wait for it to load here and go to mesh, right? And you're in the screen. Another way to do it is you right click here and go to mesh settings. Either way, you guys are gonna end up in the same screen over here. So the first thing that they want us to do here is to change it to 5%. So we're gonna do that. And we're just gonna drag this all the way down. Now, if you guys drag it, you guys see there's no number, right? So you guys should stop here and just hover your mouse or your mouse basically over the arrow and you guys can see where you guys are at. So I'm at 6 right now. I'm just gonna put it one more back down and I should be at 5. Yes. So that's what we're gonna do. So you guys are done with that, press OK. And then you want to generate your mesh, of course. Okay, you want to click yes. Wait for that to load. Okay, so now we have our mesh. We don't click solve yet, not yet. So we'd actually like to exit out of our study. And we're going to create a new one. Go back to study here. Static stress. Create a new one. Now we have two studies. One thing I forgot to do, which you guys should definitely do. It's not required, but highly suggest you guys do it, is to change the name. So you guys remember what study you guys were setting up. So I'm just going to name this one 5% for simplicity's sake. So that's 5%. I'm going to make this one 2.5, I believe, 1%. I'm going to make this one 1%. And you guys could basically just double click and it should let you guys rename it. So once you guys are done with that, I'm going to do the exact same thing. Apply a fixed constraint here at our big hole. And there you go. And then apply a load here. And have it basically the exact same way I did the first study, 180 degrees with a 10,000 Newton force. Just making sure that that's done. That looks like that. Yeah. Okay. So once we're good there, again, we want to generate our mesh. Go to mesh. Yes.
Yeah, so my one just copied with the mesh into the study tape.
Okay. Yeah, Jordan will help you out there. So again, same thing. Put it down to 1. And you guys can again check it if you hover over it. Once you're at 1%, okay. Just click yes for this one, guys. It's probably not ideal. They're saying it's not ideal, but come on, we don't care. So it's probably going to take a bit longer. We're going to wait for that. Now I have the results for this one up. Oh gosh, up here already. So I'm just going to set 2 up because it's basically the same exact process. If you guys were to do 3, 4, or 5, you guys would do the exact same things. But one thing to notice, just a quick thing you guys can see here at 1%, the mesh is a lot more defined. There's a lot more elements than there was when it was 5%, right? So that's the system basically looking at the geometry of your model and making it more accurate. So once you're done with that, 2 things you could do. Again, go solve here. You just can click both models here and solve 2 studies. Or you guys can go here to simulations, down in the tree, right click there and click solve again. Brings you to the exact same place. Both highlights blue here, blue, blue, blue. So you guys can do any of them. Click both of them and solve studies, right? It basically starts the simulations there. Okay. So right now I'm just gonna keep it there because I have solved for it. And I'm going to show you guys over here. So here, yes,
Should we change our neutrino to again like we did last time?
yes, sorry about that. I completely forgot. Make sure you guys set it up the way you did last week. Yes, so make it aluminum. Yes, thank you so much, JT, for reminding me. Okay, and then here you go. Boop. You guys can see how you basically have everything solved already, and you have multiple studies in one go. And the next thing I want to show you guys is how to compare your results. So what you guys want to do is right here, if you're in this screen right now, you're not in your results screen. So you want to click here. Okay, so now you're in your results, and up here is a compare. You're going to click on that. Now it brings you to a similar screen here where you have two models. One here, one there. And you see how one is moving with the other. I'm only controlling the right one, but the left one is moving along with it. And that's because I have the synchronized camera on. If I turn that off, you guys can see, move this one, the left one stays still. Right, so I'm gonna put that back on. And you guys can actually choose which ones you want. So let's say I wanna study that 1% and compare that. Is there? Yeah, that 1%, and I want to compare it to the 5% one. And there you go. You guys can compare that 1%, 5%, and synchronized result type. See, it's basically back at displacement. Safety factor, both of them changes to safety factor. You go to stress, both of them changes to stress. That's basically the entire gist of how you compare your results. And this isn't a requirement, but we do suggest you guys play around with it because maybe when you guys are actually doing FEA for your clubs, maybe for the industry, it's probably important to compare your results from different meshes. So that's that. I'm going to swipe back. So here is the task. I'm just gonna okay. All right, that's good. So I'm just gonna click through it again. So in total, we would like you guys to give us 15 screenshots. There's basically 5 different mesh settings. Again, the first 2 is model based, and the last 3 are absolute size. And I forgot to demonstrate how you guys could get the absolute size. So just in case you guys are confused on how to do that, give me a second, guys. My Fusion is not working with me here. Interesting. Huh. Right. Give me a second here. Okay, give me a second, guys. We're having technical difficulties. May I ask why it's like it's appearing here, but my mouse can't really do anything and it's not.
For some reason, change back to extend.
All right.
Yeah, if you want to change the screens, if that kind of stuff happens, you click FN and then F7. And then the screen will pop up.
Cool. Yeah. Thanks, Morgan. Okay. Let's finish our compare now. I'm going to show you guys how to set up a give me a sec here. Yes, all right. Finish results. There you go. Last one, last study I'm going to make. here I'm going to apply loads again. Loads and constraints. So add a constraint there, add a force here that's 180 degrees with 10,000 newtons. And here, mesh settings. Wait for that. Instead of having a model base size where you let the system create the mesh for you, you guys can go to absolute size and change it yourselves. Now this is part of the task where you guys have to change it to 5, 2.5, and 1, if I believe. Yes, 5, 2.5, and 1. So you guys basically just type it down here. 5, 2.5, and 1, basically. And follow the exact same process after that. So I'm just going to do a 2.5 here. And let me just generate my mesh. Yes. That's that. Let's let that process. Cool. Once we have that, again, we just hit simulations here, solve, or we go up here and solve it. Now I'm not going to solve it for you guys. I've shown you guys how to do multiple simulations at once. So I suggest you guys set all 5 at once and then run the simulation. That will make it a lot quicker. I'm going to go back here and I will give you guys about 15 minutes. I feel like is enough time for you guys to get through this. So leave it back up here. And yeah, for those of you watching the recording, you guys can just skip forward about 15 minutes. This would be part, yeah. So if you're unable to finish it in class, it will become the homework assignment. Are you talking about in terms of the PDF file? Yes, yes. So 1 safety factor, 1 displacement, and 1 force. Again, just a reminder, please edit the model without the y-axis, without the modified y-axis, because I believe last week we had to modify the y-axis for our last one. Please do not use that model. Use the one with just the 180 degrees x-axis angle. Yes, those 3. Yes. Yeah, is there an easy way are you talking about offsite? No, like what's the area just question? This part could be possible. What all this to this side? Reach by this side of the base.
thing is, this entire hole is treated as one surface. So doesn't matter if you click it here or there, it just exposes the entire surface. Yes, it pulls the entire surface. One surface. Yeah.
So, okay, so yeah, and if you flip the arrow, you just pull the entire surface.
Yep.
Okay,
That's
that's
the
the
other
other
way.
way. So just station, put them two inside the hole, just go inside that.
Exactly. Yep.
It's hard to describe, but you do like there are calculations you can do with them and involve like matrices and stuff, and basically you just make points along it.
Yeah.
And you analyze it at those points, what forces you have, and there's a calculation for it. And so, I don't know the best way to describe it, but that's basically what it is. So, when you create the You're gonna do 3 seconds. That's not what it says. Yeah, so that's gonna do the same thing. So in fact, you do it. So if you click, okay. And then you got it. There you go. And then you can do the same for it's on this side. So basically, you do this 2 more times, you create more studies. So just create a new one. Yeah, so just create a new. I'm gonna do the same thing again. 2.5 and one more time with 1.
And I've got some screenshots of this three, like low and then stress and.
Sort of and that deals with this and the space.
Yeah, so you have the displacement, you have the stress, and you have the safety factor. So 3 for each mode you guys make. So 3 for 5, 3 for 1, then 3 for 5, 3 for 2.5. Just a heads up, it's a bit heavy this week. So me and we counted it. And this week you guys will have to submit a total of 39 screenshots. So yeah, good luck. But I mean, the studies themselves aren't difficult to set up. It's just gonna be like this. But it's just gonna be a bit of work to screenshot about 39 times. I apologize in advance for that. So we were just on like the basic stuff. Now we're gonna go advanced settings. That's like
Advanced
another
settings.
9, 12 screenshots and adaptive mesh refinement.
Okay.
It's another like this one's I think like 15.
Yeah.
But I think we're on track to finish by like 7-ish.
Is
Is that
I don't mind about time. That's not what I'm asking for. I'm just curious.
cool? All right.
No, that's not a problem. I have most of my work done. I have to make a CAD model of something for my toy design class, but that takes like 15, 20 minutes.
What are you gonna make?
It's no. It's like they give you the model and like a drawing,
I
like
see.
a part drawing,
Yeah.
and you just have to remake it. But they don't give you like the steps, so they don't tell you like, oh, do an extrude here or evolve here. You just have to know. But yeah, as someone who's had to do that for a while at this point, I'm not really worried about it. Like I could look at it, go, yeah, it's just you start with this, whatever. So I'm not really worried about it.
Do you have an idea?
For the toy design class, no, I have no idea yet. I was gonna do a useless machine, like the ones where you have the little arm that comes
Click,
out
yeah.
and clicks it. But then, like during the slideshow showing of people's old designs, there was a useless machine in there. So now it's like, well, I mean, I had the idea before, but it doesn't come across as that when I do it now.
Yeah.
So I'm trying to think of other things.
Okay.
I haven't had like any other genius ideas of like things that would be fun yet though. Because I want to do something that you like. I want to make something that's like mindless fun, where it's like you don't do it actively. It's something that you do with other work just to keep your hands busy.
Yeah.
Because that's like what I When I'm doing work, my hands are always so jittery. Yeah. So I gotta figure something out.
Okay. Or were you able to go to catching today?
No, I didn't go to the stuff. Well, that's at the same time as this stuff.
Yeah, they're a bit short-handed as well. I heard.
Oh yeah, I got a text from the guy saying like, "Oh yeah, can you come to?" I can show you. It was
Because like Oscar, Rishi, like everyone are taking like the
Yeah,
big
yeah.
batteries now.
full load. There's like no service down here.
Yeah.
But basically, it was just like a big paragraph of like, "Hey, people have exams. We need help. Can you help?" And I was like, "I would help, but I already said to you that I was gonna help with this." So I think they got Pranav and like one or two other people.
Oh, cool. Okay.
So they have people. Obviously, they have.
Yeah.
Although I have a feeling there can be a significant reduction in people there today because there's a BCE exam.
Yeah,
So
that's a big one.
That's a big one. But yeah. After-
Cool.
on the TV,
Yeah.
and there's a guy that wants to
Oh.
Yeah, and I'm still messing with the phone because I have a few like failed like okay models that like aren't like the right temperature, right settings and stuff, so they fail in like small
Oh,
orders.
I see. Yeah.
And so I get today, like right before this, I give them a few of the things and I'll set like a mini kit. 'Cause
Okay.
I'm gonna use it for something.
Okay, I see. Yeah.
And they were just having fun with that, but it's. Yeah, well, I mean, like ASME aside, just like workload, I have a lot because I have like 4 levels. Okay. So just to get that out of the way. It would have been like 70.
Respect. Don't forget respect.
Honestly, it's nice though, because like the busier I am, the more satisfied I feel. Like
True.
if I am getting back at 9 o'clock every night, exhausted because I've been up since 7 in the morning all day.
Yeah.
I can't complain. It means that I'm actually
Doing
being
something.
productive
Yeah.
and doing stuff. Even if it's not like always me learning new things, at least it's like.
Yeah, that's true. I agree with you there. Which sub team has been like has used the most of your help? Like,
It's a little spread out. Prosthetics is doing a lot of 3D printing. Same with SED, although they also have a lot of manufacturing stuff like otherwise.
Mhm.
They're doing. Revolver is making the frame, and they're also
the
starting
soccer
to-
for the soccer.
Yeah, like soccer taking. They're doing the, but they're also making. That was just their thing beforehand, so a lot of their stuff's already designed for it.
Mhm.
And then they didn't have like the actual competition.
Ah, okay.
So they're just gonna, I don't know what the plan is, but they've been building the frame, so they got like a bunch of like canister wheels like the front of this.
Yeah.
So that they can roll the frame around and fold it up and everything. They're also starting to take a bunch of scrap out of the empty scrap too.
Yeah.
So I've been helping a lot. But I really don't have. It's a session too.
Okay.
So I'm gonna but to keep my eye on the one same with Grand Prix. Grand Prix is so late in the week that I never really get something.
Yeah.
But yeah.
Thursday. Yeah.
Next Thursday. And then small projects is just.
Nothing yet.
Nothing. Give them like a month.
It's gonna get.
chaotic.
Yeah.
Like, teaching people design practices. It's like, oh yeah.
I did see it. Yeah.
Yeah.
Yeah. My group was one of them.
Yeah. It's like, I think people really do.
They do. Yeah. Fascination is just insane.
It's a drug.
It's a drug.
Same thing with like not having recording classes for things is like skipping one class. It's like it leads to like to game.
Yeah, dude, it's very risky. All right. If you guys aren't done with that yet, it's gonna be in the recording and it's just gonna turn into homework. So, okay, yeah. And again, I'll send out the slides after the meeting tonight, as well as the recording to this. But I will be moving on in a couple seconds. All right. We good, Yvonne? All righty. Let's move on. So that was like the basic settings that I asked you guys to mess around with. Now let's move on to the advanced settings. Ooh. First one we have is element order. So for element order, you actually have two choices. One is parabolic and the other one is linear. So what we've been doing is parabolic, and the difference between the two is basically parabolic concentrates more on curves and rounds in your models. Because, I mean, you could imagine meshes probably look different than rounds because they're not just going to be like a linear triangle. So that's basically the difference between the two. And then next one is the max turn angle on curves. And think of this more like degrees of freedom, where if you guys set your max turn to be low, like your triangle can't go as far, right? Or like think of it like a line here. If you, let's say you put it to 60, then it can go only up until here. But if you go like say 180 or something, which I don't think is possible, but then it could cover a lot more, right? So that's basically it. And yeah, there you go. Just gonna leave that up here. And next. All right. The next one is the max adjacent mesh size ratio. And it's basically a scale from 1 to 3 on how small you want your mesh elements to be compared to the elements next to it, right? So this goes along with the max turn and the element order, because when you have when you have elements around curves and edges, it might be a bit smaller. And what max adjacent mesh size ratio does is, all right, so that edge has a small mesh size. We want the connecting ones to have equally small ones, or can we just make it large in like level bodies so we don't have to focus on it, right? And just focus on the critical areas on the edges and rounds and curves. And that's basically that. And the last one we have is minimum element size. And this one's quite simple. It's just the smaller, the finer your mesh will be. That's basically it. And all right, so this is the results we have. So variation in a mesh. So this is an assignment, well, guys. That was really quick, I know, but this is an assignment, and we're just gonna go over basically the advanced settings. We're gonna change the max turn angle, and then we're gonna change the minimum element size. And it's 12 screenshots, so this one should be quicker. I'm going to demonstrate it. And let me just do this so I don't have to keep going back. I can show you guys. All right. All right, so let's head over to Fusion now. I got it. Let's go. Go here, duplicate. Sorry about that. And we are good to go. All right. So I'm going to go back up, please. Please. That's not gonna work. Oh, I'm sorry. We're back here. You know what? All right, we'll do it here. So I'm just gonna delete this study and I'm going to create a new one here. I'm sorry about that, guys. All right, there you go. Let's create a new study now. Again, static stress. And we're basically gonna do the exact same thing. So you guys can skip through like the next 15 seconds if you're watching this. I'm just gonna apply the right constraints and put a load here, 180 degrees, and put a magnitude of 10,000. So once we've done that, now instead of just going to settings here, instead of just manipulating things here, we're gonna keep things as is, and we're gonna click the drop down for advanced settings. So when you guys do that, you guys can see what I'm talking about. I'm just gonna swipe back the here. So you guys can see all of them, all of these settings on Fusion here when you guys change it. And okay, I think I see what the problem is. I can't keep doing that. I'm sorry about that. I'm gonna have to do this again. Yeah. Okay. So yeah, what you guys want to do now for the first one is to keep this average element size as is. Do not touch that. You want it to be parabolic, and you want to change your max turn angle to 35. So right now it's on 60. Again, hover over the arrow if you guys are unsure what value you guys are at. Drop it down to, I'd say that's 35. Let's go. And keep it as that. Now, what the assignment is asking for is not change the max turn angle to 35 and change the minimum element size to 10 and then run that simulation. It's individual one. So for the first one, we're just going to change this max turn angle on curves to 35 and click OK. That's our first mesh. And we're going to do that again and change it to 10. And so I'm just going to do one. So in this case, I'm going to do the 35 one. I'm going to generate that mesh to 35 degrees max turn angle and curves. So that's that. I'm going to name this 35 degrees. Okay, that's good. And then I'm going to create another study now for the minimum element size. Again, static stress here, create the study. And again, just skip through like the next 15 seconds because I'll probably just be applying these loads. We're good there. And again, two ways you can change your mesh. Right click here and click on mesh settings, or go up here and click settings. Or you can actually click the drop down too. You guys can actually click the drop down here and go to, settings here. Mesh, advanced settings, go down. So for this one, I'm going to be doing the third one, which is changing the minimum element size to 10. So I'm not going to be touching this. I'm not going to be touching the max turn angle. I am just going to be changing this one over here, the minimum element size to 10. That's all. Hit enter and generate your mesh again. Okay. Now I'm going to name this one 20%. 20% min element. You guys can name it whatever you want. Again, it's not required for you guys to name your studies. I just do this. So when I look back, I know what I'm doing, which simulations I'm running. So again, to run both in once, so you guys would have to look at this pre-check. It has to be green. If it's red, something's wrong. Solve, and you can click on both of them here, both studies, and solve it simultaneously at the same time. And that will save you a lot of time. And I will be giving you guys about 9 to 10 minutes to do this one. Should be a lot simpler. It's just 4, and we'll get back at it about, in 9 to 10 minutes. I will, 6:30. I will be putting it back here. So here is the assignment. Yeah, it keeps.
Oh, I see, because when you do it, you technically duplicating the screen.
Okay.
Because, or not duplicating, you're extending.
Yeah.
Because this is a different screen than that. So it's-
Okay. I mean, it shouldn't be too bad. Oh yeah, no, but it takes like 3 seconds.
Duplicate bunch.
Oh, okay. That works.
So then now you should. have that.
Yeah, it's nice. Thanks, Jordan.
I have never messed with this stuff before. I'm just repeating.
First try. First try.
Yeah, voice stuff and like I have no idea what's happening, and then giving a guess, but doing it with like enough confidence that it's like, hey, Jason is at least convinced enough to try.
It's an educated guess. Yeah, that was a good one too.
Because I like that one's pretty straightforward, but there are plenty of times.
Yeah.
Yes.
So you know, they, should have 4 studies. Well, I'm saying for this, you have another 4 studies. 2 for the. So it should work with the study if you want, because,
So when we want to pass it.
yeah, well, like, obviously you can compare all of them at once, but when you run the study, if you piece it separately and then store it, you're not running the study every time you open them, or like save, you know? So, you know, it's not really putting any stress on the system now to do it. Another thing you can do is like, you can use cloud credits to have it run, like, just in addition on this, and then give it back, and then you don't have to send it a second cloud study the next time you open it, it just opens on your computer, really safe. Cool. The cloud study stuff is much more helpful for generators, because they have like predictive design where they, like, if you think of obstacles, it'll try to build around it, and they'll give you like a bunch of different options. Yeah.
Have you messed around with Autodesk CFD as well?
CFD, I have not.
That one's hard to set up, a bit harder.
Yeah, I've used a few Autodesk programs, but
Okay.
it's like, you know, it's like, I don't mind, I can adjust. I don't.
Right.
I don't like using for, the toy design class, but it's honestly comparing it to like NX or something. It's not that bad.
Or like, is most of it like the same?
Most of it's the same except for every single hotkey, which is what I use. And I don't feel like changing it because it's on a desktop. It's
Yeah.
gonna reset it anyways.
Yeah. But like for your toy design class, is that cloud based or do you actually, or you, if you get?
On the Rio it's
So you could, or is that like something, just an access you get when you sign up for the class?
it's on the desktops. And you can, yeah, and you get access to it. There's like a Brightspace link where you can download it.
Yes. Hmm?
So you have that 30, if you get okay. Now, and then just generate the actual piece of and then forget. Okay. I'm not sure if I changed it.
Just that. So everything else you want to keep the same. So everything asks you guys to change one of them up here. We're assuming that you guys are keeping everything else the same.
So the settings.
Sorry.
If you're not sure, just gonna look at 35 and 10. Yes, then just change that setting. Yeah. That's all. Do you want to say
Settings, but we'll get into that in just a bit. 4 more minutes. 3 more minutes.
Outside schedule.
Yeah.
Normally it's. Yeah. Target. They will now follow those the whatever. Not to. The but this one. Yeah. Let me show you one other thing. Oh. I mean,
Oh, that's fair. But yeah, no, I've been playing D&D with friends for like 2 years. One of them.
Make your own like.
And it was a nice way to kill time. So I was like, I'll make one of one of the characters I have for it. So. But yeah, that whole process probably has taken me 24 plus hours to make.
I mean, yeah, it looks very like detailed.
Question? Yes, so, I'm just going to different results. So this is. Yeah. That's the intent. But there's many different triangles there, in terms of simulation. So basically, every little part of this mesh, like where there are smaller parts, is a part that is going to analyze individually. So, like here, since there's a lot of like larger movement and not really anything specific to the part, the forces are really distributed. They're just kind of stretching it along. You don't need that manipulation. So because you just there. But the longer you continue this circle, like the other around it, the forces are more distributed and it's going to stretch out into this little bit. Yeah.
All right, guys. So we're going to move on. Not okay. Gotcha. Okay.
So by adding more of this like mesh to that area, it will better, more accurately analyze like what those are, because it will do like more calculations around that area. Or what does the max angle mean? What it really means is just like I believe it's how tight the angle of the triangles is. So when you lower the angle of the triangles, you can fit more triangles along the surface. So yeah, so like if you have like a triangle is like this angle is the one that's decreasing. So when you decrease it, you can fit another one side by side, put them upside down, like taller. And basically what it's saying is it's like around the edges, that kind of stuff. So it helps analyze that. Okay, so if I decrease the max then I'm going to compile faster. And I'm going to triangles and we complex areas with these steps here, which should be results. Yeah, to give you a more accurate result, it will probably take a little bit more time because you're fitting more triangles in the mesh. So each one of those takes a little bit longer to calculate. But it will be more accurate. And you know, obviously you might not want to waste time analyzing a bigger part in certain places where the code is. I mean, this piece of just drops. So you can just kind of ignore that area and then just that basically it's focus on. Okay, what was this? Yeah, so you're gonna change that to 10 and then
Okay. So again, if you guys aren't done yet, if you guys are watching the recording, just pause. And if you guys hear, it'll be in the recording. So all right. So let us move on now. This is our third setting. So we've gone through the general setting. We've gone through the advanced setting. So now we're at our last one, which is adaptive mesh refinement. So this is a bit different from the previous ones because in the general and the advanced settings, we sort of created our own, like we moved the slider around, right? And there were quite a number of sliders. So the difference with this is now in adaptive mesh refinement, we're actually asking the system to analyze it for us. And how this works is the system will run simulations after simulation, starting with a very coarse and very inaccurate mesh model. And it'll keep going, making it more, it'll make the mesh smaller and more accurate until it reaches a certain degree or it reaches a percentage of, how do I say it? Like it compares itself to the property of the materials, and the more accurate, like it, once it gets accurate enough, which you guys will be inputting yourselves, the system will stop the simulations and give you guys the results. And this is particularly helpful when you're analyzing critical regions. So like, let's say you're analyzing a crack in a model. You guys can accurately see how much displacement, how much stress is applied to that specific crack using adaptive mesh refinement. So moving on here. Yeah, so here it is. And yeah. So this is what I was talking about. The system will keep running the simulations until it's within a specified value, within the range of a specified value. And so there are a number of parameters that vary. I'll just put them all here right now. I'm going to talk about them one by one. For the maximum number of mesh refinements, you're basically telling the system, all right, so I don't have too much time in my hands. Just refine it about like 4 or 5 times. That's actually quite a lot. Let's say 2. So what the system will do is, all right, it'll run the simulation with a very coarse mesh setting, and then it'll run it again now with a finer mesh setting. But since you only gave it 2 iterations, the system will stop after that and give you the results, right? But you're allowing the system to do its thing. It'll set up the mesh settings for you. And our next, okay. The next one is results convergence tolerance. So this is basically, you're telling the system, once the percent change in results from the previous iteration to this iteration is less than a specified value, just display the results, right? That's like, we're just saying like the change after that, we can disregard. And the next one is portion of elements to refine. And that basically specifies how much of the model goes through mesh refinement. So an example of this is at 10%, only the top 10% of the critical portion of your model will go through further refinement. So you can imagine, say, when we have an edge of a surface, of course, that edge will encounter the most stress. So that will be our most critical point of the model, right? So the system will look at that, and the top 10% of the model, which mostly will be that edge, it will go through further refinement, but everything else within your model, it will most likely stay the same or be about the same, even though they go through like a bit of refinement where it gets a bit more accurate, but it won't go through as much change as that critical point. And the last one is results for baseline accuracy. So for this one, it basically compares the results of your simulation to the yield strength and the equivalent stresses that Fusion has within its system. So this is when your materials really come into play. So let's go. So this is a visual representation of what adaptive mesh refinement actually does. So you guys can see from the leftmost to the second leftmost, that point where that crack is, where that red area is, you guys can see the mesh actually got a lot more accurate. But look at the top left, the triangles didn't really change in size, right? So that's what the system means. It looks at the critical points and it gets more accurate there, but to save time, the areas where the system thinks that it's not very like valuable information, like the top portion, it doesn't really change. And as we go along, it gets more and more and more refined. It gets more accurate to a point where and your rightmost now, you can barely see where each element ends at that red area. So that's basically what we're going to do right now. So before we get going, there are 4 predefined options for you already. So these are none. And basically the system is just going to run it once with the very coarse settings and go like, okay. And low. And then we have medium and high. So if you guys see here, maximum number of mesh refinements keep increasing, right? So again, that takes more time. Results convergence tolerance, which again, just to refresh your memory, is the percent change in results from the previous iteration to this one. It decreases, right? And then the portion of elements to refine increases. So let's go. I'm just going to go back here. So we're looking at this right here. And instead of just looking at that red area, if we increase our portion of elements to refine, that's most probably the reason why the rightmost there has really small elements, has a very refined mesh. And we could achieve that by increasing our portion of elements to refine. So again, increases, there you go, none, low, medium, and high. And what we would like you guys to do now is to test out each option. So I'm going to go here. None, low, medium, high. So that's 4. But in addition to that, we would like you guys to propose a customer refinement control. And what that means is you guys are now able to change your own maximum number of mesh refinements, results convergence tolerance, portion of elements to refine, as well as results for baseline accuracy. And I'm going to demonstrate to you guys how you guys can switch between the 4 as well as create your own custom refinement. So here. All right, so I'm going to create a new study. Again, static stress. You guys can just like skip 15 seconds over this. Fix that. Okay, create a load here and over here. That goes 180. I mean, you could go both ways. I made it negative 180, but if you made it positive, like it doesn't really matter. Again, 1000 newtons is the force to go with. And now you would like to go to manage the settings here. And you can find adaptive mesh refinement under mesh over here. Right? So I'm going to repeat that. You go to manage, you go under above manage here is settings. You go here and you go adaptive mesh refinement. This is where you find your slider and the options for you to custom. I think another way you guys can do that is drop down. You guys hit the drop down. Adaptive mesh refinement is actually the bottommost drop down option right here. So it's predefined at none now, but we can switch it low, medium, high, right? What you guys can notice is you can't actually edit any of this because it's predefined by the system, right? But when you go to custom here, this is when you guys can change it. And so what we're asking for you guys is to test out each of them. So you guys want to study with none, give us 3 screenshots, another one with low, give us another 3 screenshots, then medium, and then high. You do that, and then you guys can actually create your own. We're asking you guys to create your own. And you can change the number of mesh refinements. Please do be careful with this, because if you guys pick an absurdly high number, it'll take you forever to run. And results convergence, and portion of elements to refine. So I would like you guys to stay within bond misses stress, because that's what we're focusing on. So that's that. And you want to make sure when you're doing none, low, medium, and high, your results for baseline accuracy always stays as bond misses stress. That's what we're looking for. And so yeah, so right now I'm just going to make my own custom study here. Let's say I'm just going to make it 5. Results convergence, I'm going to make that 10. The portion of elements to refine, I'm going to increase that to 60. Let's hit OK there. And let's generate our mesh. All right, so I'm actually going to change it up a bit and show you guys the difference if I change the settings. Do you guys see? Because the system is going to change it while it's doing simulations, it's not actually going to change. It's not going to ask you guys to change, to update your mesh, sorry. And let's compare that actually with what would happen if we change the mesh settings just normally, right? So right now we have it at 10%. Let's say we drop it down to, what is it? 3%. Right, you see here, it's out of date. It's asking you to renew your mesh. But that's different when you're dealing with adaptive mesh refinement, because again, the system will be changing it for you. So, I mean, I'm just going to renew it right now. Yep, you are. Oh, sorry. Generate mesh. Okay, so again, quick summary. The only things we're asking you to change right now is to either slide the sliders, which you guys will have to do. So three screenshots for none, 3 screenshots for low, 3 screenshots for medium, 3 screenshots for high, and 3 screenshots for the custom mesh refinement that you guys will be making. I'm gonna click OK here. And I will only be doing this one. You guys, I would suggest you guys to set up all 4 and then run it at once like we did earlier, but it's up to you guys. So I'm just gonna solve this and I only have 1 to solve. I'm gonna solve that. Let's see what we get. We get through that.
Oh, yeah. That's not hard. Pretty good. Oh, okay, so I'm not gonna jump up to the- Okay. Yeah. Cool. Yeah, figure out whatever, I mean, this doesn't matter. We don't like, we don't see different results. Yeah, just be careful, don't put like a high number, and that makes you maximum, number of max assignments. And if you're gonna put a higher number, I really recommend you to increase your portion. I mean, this isn't a high number, but if you're gonna go like double digits or something, increase your portion of your fine. Yeah, it's taking a while. And the generative design stuff is ages whenever you want to try that. Show you as well different models. This is what they're called models. Oh, yeah, like. So all of these lines are bones. You can be like down this round. Do you make like joints from it? Like joints as in like connecting together? So I don't have joints in it. Trackpad, but like I just wanted to show like mainly by go to but like if I go to like these, like all of this is like mesh. Oh yeah. So like I've gotten very used to using meshes because like all of these are like vertices that you can pull around and mess with. Right. So every time I see stuff like this now, I'm like, it makes sense. It doesn't faze me anymore. Yeah. Because I'm just like so used to it from like making my own meshes.
Right.
Kind of like funny to see the simplistic ones that the FEA analysis comes up with.
Yeah.
It's like I know how complicated it can get now.
Yeah, the Blender ones look insane.
Yeah. No, and mine is very simple compared to what's. Learning the program is one thing, but understand, I have a lot better appreciation for animated stuff now.
Oh yeah,
That's
that's insane. That's insane.
like the skill that it must take to do that kind of stuff and patience too. Is like not. Yeah. Sorry to interrupt.
Oh yeah, no problem. Okay, guys. So now my simulation's done. You can hit the results here. So again, I'm sorry, I did not rename my study, but this is what it looks like basically. So it took a little longer just because, again, the system Fusion 360 is now running the simulations for me. And based on what I set the maximum number of mesh refinements to be, they're just gonna keep running it and make it more accurate. So again, that's the safety factor, that's the stress. And again, if you want to compare, go up here and hit compare. And on the bottom left, you guys can switch the study here. Let's try 1% here. And that's 35 there. And that is it for this. So you just basically have to create 4 different settings. Once you're done with that, you will be done for this week. So again, I'm going to go back here. So 15 screenshots in total. Once you're done with 15, you will be good to go. So for those of you watching the recordings at home, if you guys are stuck at any step, just pause, replay, or if you still can't figure it out, shoot me or Bernardo a text and we'll get back to you. But otherwise, here's the submission link. I'm gonna keep it up here for about a minute or two. Yep. And again, guys, this link will also be posted on Slack. So don't worry if you guys aren't able to scan it right now. I'm gonna post everything on Slack tonight after I've converted the recording. And yeah.
So you did. And you went to the top of the first one. But you know, if you added those two bodies, you put like a seven scale like that. Unless let's say, I don't know, make a function of strong, so like it's on paper, this thing, this spec of the function, because I no longer do. Yeah, so you can do that kind of stuff. So like, you can do, you can put it in kind of a, so you put it in the basically say this one. No matter what you do. So that's what happens here with this one.
Okay. And that will be all for this module this week. I'm going to stop sharing my screen.
Which is why it's really important.
And I will end the recording now. Thank you guys so much. And I'll see you guys next week. Again, if you have any questions, shoot me a text or shoot Bernardo a text. And yeah, have a good rest of your week, guys. Don't forget to submit your tasks. Thank you.